You want to all the way?
You can make them as long as you want. Yeah, that is good practice. So I can't make mine any longer, Patrick, or it's gonna hit that thing down there. But they have to be long enough to cross. Okay, guys, like regular students who go like this, and this line is like, maybe like this, and this line is like this. And they're like, but they don't cross. Like they do, just keep going like this. Okay, so that's all I'm saying. Is they have to cross. There will only be one point of intersection. And it's straightforward. Any other questions on this one?
So that's it.
That's it. Then move on. Then you're done. Okay. Let's review substitution and then we'll get to elimination. Most of you guys decided you like elimination better. However, part of your mark will be using the process that's most efficient. The only time substitution is most efficient is when you have a variable already isolated. So this one here, y is already isolated. I have 2x minus 13 is equal to y. They're the same thing. This one I want us all to do substitution. After that, I don't care. You can choose whichever one you prefer. Yeah. And it will be in your workbook, just back a couple pages. So I was hoping we didn't need them today. No. Oh.
That's another question.
Sometimes I hit the button on this, but yes. You have a question? Oh yeah, I saw it. Sorry, I think I had a question. Patrick, you're good?
Yeah.
Okay. What are we doing here?
Okay, so you want to substitute 2x for 2y?
Well, the whole thing, right?
The whole thing? Substitute that.
Yeah, for y, okay. How did you know it was going to go take the place of y?
Pardon me?
How did you know it was going to take the place of y?
Because it's 13 and x is the equation.
Yep.
And y is trying to make y.
Yeah, you want to substitute in for the same variable that's already isolated. Okay, so y is the same as 2x minus 13. So y is coming off the court and its replacement is going in its spot. Everything else is staying the same. Okay, Matthew, what does that look like when you replace it?
Replace the 2y with okay, so it looks like x equals, or x plus, bracket, 2x, 2x, subtract 13, equals negative 6. Then you're going to want to do 2 times 2, 4x, then 2 times negative 13, negative 26x, or negative 26.
So basically, we substituted in. You will usually have a distribution that has to happen, so distribute, and then we're in the process of simplify and solve.
So like, you're going to add the x. Sorry, you're going to move that negative. Okay, so we can move that negative over to the other side and go positive.
Yeah, and Patrick said we can put the 4x and the x together, right?
Yeah, that's it.
Yeah.
Put the x together, which would be 5x. That's 20.
Yeah.
Then 5x divided by 5, that's 1, or that's an x, and then 20 divided by 5 is 4, x equals 4.
Okay, that ended up becoming algebra once you did your substitution. So this part here is the grade 10 concept. They want to make sure you substitute in the expression for the variable it's equal to. Okay, just like if you're taking a center off the court, you're putting somebody who knows how to be a center on the court. Same skills going in the same spot. Distribute, calculate terms, and solve. Any questions on this one so far? Yes, Marshall.
So like, for the, you know how we had first time I think we went to like 26, but is that
Yeah.
Like, how did you put all that equation in the second?
So this went in the place of y.
Y equals 2x minus 13?
Yes.
So you put it all. And then you just do x plus 2 in brackets, 2x minus 13 equals -6.
Yes.
Now you solve for y.
And then it becomes algebra. Yeah. So we solve for x. Yeah, this is definitely like your algebra chapter of collected distribution, collect like term solve. But it was a matter of how did you get there, Patrick? So the y came out and that went in. So it was 2y, but now it's 2 times this.
Substituting 2x minus 13
Yes.
for 1.
Yes.
I don't even know why.
That was going to be a question. Are we done? But Patrick said, well, how do we know y equals? Okay, Logan, what's the fastest way of getting y? I have x. Good. Go back to this equation. Y equals 2x take away 13. And x is 4. And then I will, so somebody asked me at the very beginning about therefore statements. Basically, your POI is your therefore statement. So just put it together as a point, x, and then y, and you're good. But I highly recommend, what did we say, Patrick? Checking this, right? So grab a calculator or whatever, you would know it works in the first one, check the second one. 4 plus 2 times -5, so 4 plus -10 is -6. Just plug it all in your calculator. Yes.
Is the substitution?
Substitution is easier if this is already isolated.
Well, what if there was like a 5y?
Then you would not want to do it because then you're working with 2/5 and -13/5 the whole time.
So that's what I was.
Yes. So if the variable is isolated, so look through your test, you'll find one where the variable is already isolated, do this. After that, take elimination, or if you love substitution, keep going with it. But you may have to work with some fractions, okay? Okay, so now we substitute elimination. Patrick, there's the steps. Do you want a quick picture? Elimination, you need to make sure they're in the same format. Oh, sorry. You need to make sure they're in the same format. You need to make sure one coefficient is the same. And then you're going to add the opposite to eliminate and solve for your point of intersection. So looking at this, are they in the same format? Is one coefficient already the same?
Yeah.
2y and 2y. Yeah, so I just have to make sure, do they have opposite signs?
Yeah.
Yes. Okay, so I can immediately add because they have opposite signs. So what does this simplify to? I know Matthew knows. This is 0, but what about the rest of?
2x and 8x. 8x. Oh, we're adding. Oh, 8x equals 24. And 24.
Yeah.
Divide by 8.
Divide by 8. And you have your first part of your point. What's x equal? 3. So most of the time, this is faster than substitution. But my advantage was that twice already had a coefficient of 2. So sometimes it's not as quick.
When you say on the test, like solve this by using.
No, it says substitution or elimination. So that way you do get to choose, Patrick.
I don't know. See what the cheat.
Then you don't need to answer, man. Tell me what to do.
This is the big leagues now, Patrick. How am I getting the rest of my point? Matthew.
Basically,
That's
what
true.
you're gonna do is a y.
Yeah.
You're gonna choose which one is easier, so I'm gonna top one.
Okay.
So you're gonna put x in the 3, so 3.
This is okay, hold on one second, and then you can take it away.
3, 2y, 19, 3 times 9, plus y equals 19, and I go to the sides, 10, then 5.
Nice. So the point is 3.
We're gonna put 3 and 1.
9 plus 10 is 19. 15 minus 10 is 5. Okay. So a couple things, remember, put them in the same format, make sure they have opposite signs with the same coefficient. You're going to add, remember the phrase to add the opposite, find one variable, plug it in, find your other one. Any questions on this one? Okay.
Oh, yeah.
Yes, Patrick.
To find out y, you just use like, you just did like, you just put x and you put the
Use your sign.
substituted x for 3.
Yeah.
They just no question.
Yeah, actually you could do either equation.
Like you choose.
Yeah. So let's say Patrick picked the bottom one, because you're like 19 is bigger than 5, so you need the bottom
So
one.
it's gonna be 5 times 3.
Yeah.
Minus 2y
Equals 5.
equals 5. Sorry,
Yeah,
equals 5.
yeah. So then 5 times 3,
It's 15. And then you just divide the 5 side, which then equal negative 2y would equal 5. Or negative 5.
this is going to be negative
Oh,
10.
10,
Yeah.
negative 10, sorry. Yeah. And then you would divide negative 2. Negative 2.
So see how you got the exact same thing?
Oh, yeah.
So it doesn't matter which one you pick. Okay? Just pick the one that you, when you look at it, you're like, that one looks a lot easier to see. Okay?
And will there be any
Yes. Yes. Very good. Okay, this one we can choose. What are your thoughts? Interesting. If you guys are like, I would not do substitution on this one, do yours by elimination or on your worksheet. We're going to compare. Okay? So, elimination. Do we still want to do this one by substitution? Substitution, elimination, or else split right down the middle. Possible that are neutral. Okay, that one, I'm going to do this by substitution because the next one I don't think we want to do by substitution. Okay, Lisa, you said substitution right off the bat. You can do them both, but you can, yeah, so keep going out. Lisa, which of these variables would you isolate for? Which one is positive and has no coefficient? Yeah, the x right here. So if you're going to do substitution, which I'm going to demonstrate, do elimination. If you guys don't want to, if you can ignore me, feel free. If you don't want to do substitution, I would substitute for this variable because all of the rest of them have a coefficient in front. So is that what happens when I isolate for that for the x? The 0 doesn't need to be there because it's nothing. Zachary, can you keep going?
So then we put negative y minus 3 minus y divided.
Why did you make it negative?
Because we moved it across the equal sign. We're doing substitution. If you would want to do elimination like independently on your sheet, Patrick, we can compare. We'll get the same point of intersection. So if you don't like substitution on this one, try by elimination. Well, the last one was already isolated. This one we had to do that quick step, and then we could keep going. Mark, you're going to keep going?
Yeah, so negative 9y minus 6.
Yeah.
So then we have negative 15y equals 5.
Okay, then
And
what?
divide both by 5. And then y equals
Guys, often students, when they don't get a whole number, they start to question whether they've done it right. This one ends up being a decimal or a fraction. So just be really careful when you're isolating that. This one ends up being negative 1/3 as a fraction, which is fine. Remember, lines don't always cross on whole number points. The students think all of a sudden they're making a mistake. But if you keep going, you can check your answer. Okay, so keep going. Even if like your inner critic's like something's wrong, it's not a whole number. keep going and I will check at the end. Okay? How do I get x? Good. X equals negative 3y. And y is negative 1/3. What's negative 3 times negative 1/3? Or ask your calculator. Close. What's a negative times a negative? Positive 1. I'm just needing to say this out loud before I forget. Some of you guys have not been bringing a calculator and relying on phones or laptops, which you can't use.
You plug that in your.
So I would strongly recommend tomorrow when you're doing your assignment, find your calculator at home or buy one because you're going to want to know how to use it on Monday. Awesome, awesome. Except for the 3 was negative. Yeah. Yeah. Who does not own a calculator right now? Okay, so we all just need to find ours and then remember how to use them. There's a fraction button on all of them, so if you're not sure how to do this, ask me today when you're doing your practice class and I'll show you. Often it's an ABC button on your computer. Okay, so then we have this weird point.
We go through elimination also.
Yeah, the next one's gonna be elimination.
No, this-
Oh, this one, yeah. Okay, so I said sometimes you start to question whether you've done it right. So if I go back up to the top, I know that 1 plus 3 times negative 1/3 is 0. We just tried that one. 3 times 1 is 3. This you're gonna have to trust me, you're doing your calculator. 6 times 1/3 is 2. So 3 minus negative 2 is 5. So you can check it, but rely on your calculator if you hate doing fractions. No, I know. Okay, so please check it, and then you'll know, even though it's a fraction, I've done it right, you can still be confident. They're not always whole number points. Okay, so Patrick's asking me to do this one through elimination.
You would switch the sign. Right?
Well, first of all, do you have a variable with the same coefficient? No, so we have to do something first. We have to make both of these 3 or both of those 6. Which one do you want to do? You want to do equal 6?
Yeah.
Okay, so what do I have to multiply this one by? Okay, do I have to change this one? No. Okay, so I get 2x plus 6y equals 0. So these are the same, right, Patrick? Do they have opposite signs? Okay, so I can immediately add, right? So 2x plus 3x. Okay, and 0 plus 5.
Fine.
5. So divide by 5, x is 1, right? Which is what I got over here.
And then y.
Yeah.
I can choose whichever column I want.
Yes.
The bottom. So it's 3 times 1. So 3 times 1 minus 6 y equals 5. So 3 times 1 is 3 minus 6y equals 5. Now bring the 3 over. So then it's 5 minus 3, which is 2. And 6 divided by 6 and 2 divided by 6. Oh, negative 6 divided by negative 6. So
Nice, negative 1/3, which is what we got over there, right? Okay, so it really doesn't matter what method you choose.
like, what would make it easier to use? Question like the point.
Yeah.
What was easier for this question?
Probably it didn't really matter because substituting, like isolating that was so quick. So really it just depends on which steps you can work with. If you're concerned when you rearrange, you're going to make an error right here,
Yeah, I
then
don't
just
agree.
jump right to substitution. I mean, right to elimination. Yeah. So then, Patrick, what I would say then is the only time you're going to do substitution is when the variable is isolated. Everything else to elimination. Cool. Yes. Okay. We have two last questions here. This one says either substitution or elimination. Your thoughts about your options. Joel. Okay, so what's making you lean toward elimination? Good. Okay, so Joel's saying this could be easy to make them both 20y, they already have opposite sides. What are some of your other thoughts about your options? Yeah, you don't have a single variable that's positive with the coefficient of 1. I have a 6, I have a 3, I have a 5, and I have a 4. All of them are going to be really clunky to rearrange and to work with. So I would say don't pick a substitution. You could do it if you really like a challenge. Otherwise, just pick elimination. Joel's saying we're going to make these both 20. Or, oh, sorry. No, I just took that one.
Or you could do, you could just slow down that video.
Or you can make those both 18. And it's totally fine, whatever you choose. But Joel, you suggested this, so we'll go with that. What am I multiplying the top equation by?
5, 4.
And the bottom one? So please remember to multiply everything by the number that you've chosen, including the number on the end. Nothing. Yep.
4 times 6. Or sorry, it's not 30, it's 24.
Yeah.
And then 4 times 5 is 20, and then 4 times 20 is 80. And then 5 times 2 is 15. 5 times -4 is -20. And then 5 times 23 is 23.
115.
Or making the y's even?
Yeah.
Okay.
Anyone want to verify 115?
Yes.
Okay. Okay, so you could have kept your made the x's the same. We chose to pick the y's.
Right, easy.
Yeah. Go ahead, Matthew.
Okay, so then you're going to take away 20, and just take that out. And then
Yeah, so they are give opposite signs, so I can add.
goes out, and then
Yeah.
you're going to put add 24 by 15, 29. 29.
Yeah.
Then you're going to add 80 plus 115, which would be 195. And then 39 divided by 39 was x, and 195 divided by what's that?
5.
Yeah.
Okay. Okay.
And then you solve for y, right? So you-
Yes. You could use these, but we just made them bigger. So I would avoid those. You can.
Say more.
I would go back over here and pick one of those. Which one, Logan? The top one or the bottom one? Top one. 6x plus 5y equals 20. Okay. Faster than I can go. 2.5. Okay, so I'm sorry, 5y equals negative 10.
10.
So y is fantastic. Again, you guys don't have to write all these steps. I just do this for my notes. So you can follow what we've done. Feel free to just skip the 3 that I was still working on while you were mentally ahead of me. 5, -2.
We're looking at, how many times do you think we're gonna have to graph them? It's just for the first
No
part.
more than 2.
And it's just for the first part.
Yeah.
And it's just for the part where it just gives us the way where we have to do the point of intersection.
Yes.
That one?
Yeah. 5 -2, I'm going to check here. 30 minus 10 is 20. 15 plus 8 is 23. Fantastic.
I know something.
Okay, we have one more, I think. You sure you don't want to wait for the word problem? I think I have one more. Okay. I tried to pick one that was not y equals mx plus b, because you guys are pros at that one. So I'm trying to pick one that was a little bit different, but again, you guys will have choice on the word problems, okay? This one says Greg works half as many hours a week as Paul. Between the two of them, they work a total of 48 hours in 1 week. How many hours does each person work, Ian? Okay. Can you start me from the beginning? Like, what was your variables? What was your equation? Okay. Thank you for using that. That makes sense. Fantastic. Okay. Yes. Okay, so all of a sudden right off the bat, we have Ian and Zach who have both exactly the right path, but different equations they're working with. So Zach thought of it as the opposite, that Paul works twice as much as Greg, which is the same thing. Ian saw it as exactly the way it's written. So Zach, if you keep going, you can say things. Okay, Ian, what else do you have? Oh, so you've already, okay, so you actually worked with the other equation? So did you work with this equation or this equation? Okay. Both of them would work, because they're the same thing. This one, we just multiply the 2 over here to isolate the p. They're the exact same equation. So if you don't like working with fractions, use this one. How did you write, Ian, that between both Greg and Paul, they worked a total of 48 hours? Okay. Here's my linear system, and you have a choice of substitution or elimination. Ian's saying he did substitution. Would anyone try to do that by elimination based on those equations? Matthew might. Anyone else? No, who would choose elimination with this one? Anyone? Okay, so we're all going to do substitution. I would say that's your fastest bet. P is already isolated. So you would have to do a lot of rearranging here to get to elimination. So let's just go with substitution. Ian, can you go with what you did? Okay. So what do you have right here? Already, yeah, what's that? Yeah, you have the number of hours Greg works, just like that. It's done. Yep. Or what's your other option? You know what did you do? Did you plug it into this one? Okay. Or you could just double G and get P. Either way is fine. What do we get for Paul? 2 hours. Exactly. Oh, I know. Okay, this is the word problem. This is a really perfect question that Zach's asking. We don't really know what's X and Y here because it's not like just a general graph, right? So instead, what are you going to do? The therefore statement. So therefore, Greg works 16 hours and Paul works 32 hours a week. Zach, this won't be impossible to figure out like your independent and your dependent variable, right? Because we're talking about 2 different humans here. So just do a therefore statement instead. Let's see if they meet all the criteria. Is 16 half of 32? And is 16 plus 32 48? Done. Okay, so at first you're going to be like, I'm not quite sure if my initial equation is right. Keep going. Check your answer on the end. You'll know if you've done it right. Okay. This one I thought was maybe a bit tricky, but it's simple at all. Any questions on this word problem? Is it good? Okay, so we still have 30 minutes for a break. So what I'm going to do, so we have lots of time. I want you guys to be able to ask me questions, and I want you to be able to do as much practice as possible before we're no longer in each other's presence. I'm going to hand you two things. Patrick, I want you to look at me so I don't have to repeat myself. This is your test booklet. This is your multiple choice. You will have multiple choice at every single math test. So I have grabbed, you like that, Joel? Often you have multiple choices that make sense enough. These are the ones, the questions I can ask you very quickly, that you don't have to show me a whole bunch of work. So really what I did was I took 23 from my test bank. They're all relevant. There's nothing in here that is going to be extra, like, let me spray with this. Nothing on Monday will be different from what you see here. This comes you from multiple choice.
You should tell us them.
This test booklet here, I'm giving you guys opportunity to do the exact same corridor as Monday. You will do besides multiple choice, you do graphing. Then you're going to have some linear systems, substitution or elimination. So please be efficient in what you're doing. And then you've got your selection of word problems. So the format might be the same. Multiple choice, graphing, substitution, elimination, word problems. Okay? It will be, well, you'll have probably, I would say, minimum of, you anticipate like 15 multiple choice. So that would be less than this. I've over prepared you. Okay. You'll only have one or two graphing. I may just leave only one on there, Patrick. And then similar with your linear systems and your word problem, I'm actually giving you extra practice in here. Okay. Tomorrow, I will post the answer key to this, and in our Zoom, when you guys are getting ready to do your assignment, you can ask me any questions that you have. Okay? Any questions right now on what you're doing today, though? So I think I start with COVID makes everything complicated. You guys okay with this?
Where's the most?
Hold on, I'm going to give them there. You can see it.
Patrick, are we just double check?
Guys, I don't want these back. This is for your own practice. Okay, I'll post points on Etsy, and you're post the answer tomorrow. No, actually, half an hour. Do your work more. Oh, let me see if I can find one nothing. Yeah. Three? Two pencils. Not good, maybe. Spray it.
Not your face.